Hi, I'm Joe Keating, Senior Director of Applications Engineering for Infinite Power Solutions. We're a Denver, Colorado-based manufacturer of THINERGY microenergy cells, which are solid-state, thin-film rechargeable batteries. In this video, I'm going to talk about our application development platform. ADP Kit is a development tool that IPS has put together to allow people to, or developers, to get a very deep understanding of our technology, along with methods to connect and develop their own applications. It's very similar to an embedded development system, such as an emulator system that's used for microprocessor development, except instead of handling signals between the boards, such as digital signals, we provide power. So we allow you to understand your power system and the energy flow between the battery and any charging sources you may have. So the kit contains the application kit main board here, which is like a battery lab on a board essentially. 3 microenergy cells. In this case you get the MEC201, the MEC220, and the MEC225. So you get one of each of our 3 standard size products that are currently available. Additionally, you get a plug which allows you to run the kit independently off of wall power, and the plug has various adapters for different international standard plug sizes. You get a USB cable and a cable here that allows you to connect external energy harvesters easily to the device. We'll go through some of those in a minute. To begin with, what I'm going to do is connect the kit through the USB cable to my laptop here, because you can also power the kit from, for example, a computer, and which also gives you the ability to data log or stream serial data into the computer from an external, from the ADP kit, the externally connected ADP kit. So now I know that my serial data log is active. So what does this allow me to do? Well, basically I can take an MEC card, and let's say I want to get a discharge curve so that I can take the data, for instance. So anything that I record here on the laptop I can put into a file. I can stream that out to a CSV file, and then I can take that and import it into Microsoft Excel, for example, so that I can do analysis on the discharge or charge curves later. So let's say I have an application that's going to require a for example, a 10 milliamp discharge, constant discharge. So what I can do is go into demo mode, set the constant current, and then go through the options to the 10 milliamp. Now if you noticed, I can set an adjustable value too. So let's say that my current was 4.5 milliamps, for example. So I can set a range from very low current, around 20 microamps, all the way up to the maximum current, which is 40 milliamps on the device. So now if I hit start, so what I see here is I get my battery voltage, so I can see what the voltage on my MEC is during the discharge, and I also see an approximate state of charge is displayed here, plus the time. But the thing to note is that this is also being transmitted to my laptop, so I'm also recording the data from this discharge. So here I'm going to quit the discharge. So it has exited the discharge mode, and you can see up here on the screen it has produced an end, and then I'll proceed, and now it will ask me if I want to recharge. So I'll press A, start, and now what it does is the ADP kit has its own built-in charge source. So it's supplying 4.1 volts, which is the nominal accepted standard charge value that we recommend for our microenergy cells. And what I'm doing is I'm looking at the current that's going into the MEC. Now, since I didn't do a full recharge, the amount of current the MEC is going to be lower than the peak standard current you're going to see, but basically it started out at around 700 microamps, and you can see that the charge current is decreasing because it's a constant voltage recharge, which will allow the MEC to self-regulate its charge current. So that's a standard charge discharge method. Now let's say that I wanted to see what can be done with a standard energy harvester such as a solar panel. So in this case I will quit, exit the recharge. I'm going to connect this energy harvesting interface cable that we supply with the ADP kit. Let me show you that for a second here. So this comes with what we call our passive power management unit on the end here, and the PPMU allows you to connect DC and AC sources, and also provides a 3.3 volt regulated output at this header here. And that can allow you to play around with other types of wireless modules very simply off the energy harvesting bridge. So I'm going to plug in a solar cell because I have an amorphous silicon solar panel right here. So I'm going to plug that in. This is from Samuel Morton. This solar panel is also included with the kit so that people can get started right away. Solar is the most popular method for energy harvesting currently available. So that's why we include a simple panel with the kit. So I have to move a switch on my ADP kit to enable the energy harvesting header, and then if I reset the board, what we're going to see is it's going to detect this energy harvesting cable is connected. Runs through quick calibration. So this is EH interface active, and it even displays it here over the serial data log. So now I know that my energy harvester has been connected and recognized. So what I'll do is put it into pass-through mode. Now there's a couple of different modes. You can do bucketed mode where you collect some energy over a long period of time, say into a capacitor, and then you can flip a bit, which will tell the ADP kit to connect the charge source to the MEC for a short period of time to dump that energy. The other method is pass-through, where any energy that you supply to the energy harvester is just directly connected to the MEC and supplied directly to the MEC. The ADP kit has protection in it that will prevent you from overcharging the MEC if the voltage or the current levels go too high from your energy harvester. So there is some protection there for the MEC, and that's another reason why you want to use the ADP kit when you're developing your products, is because if you were to just put the MEC on your product without first debugging it, you would probably end up initially damaging the battery if you have a short or other problem on your board or your charge system isn't working correctly. So in this case, I have the pass-through mode set, so I'll start my recharge. And right here what I'm seeing is that I'm getting 4.06 volts on the MEC, and I'm getting 190 microamps, and I'm logging it over here on my laptop as well. So this solar panel is actually doing pretty well right here. It's producing almost a milliwatt in this indoor lighting, which is pretty good. This is a solar panel that is tuned towards indoor lighting, which is fairly common for many of the energy harvesting type applications. Now, one more thing that you can do with it that is very helpful for people who are developing these types of applications. I'm going to quit out of this mode. I'm going to exit back to my main menu. Here in the Sentry mode, now the Sentry mode is a mode that allows you to recharge indefinitely from an external energy harvesting source, but it also allows you to connect an external battery, or external load. So let's say I've developed a small application like this. So this is our LED demo card, and it blinks LEDs. It has a TI MSP430 microcontroller and some power management electronics on it, and uses a solar panel for recharge. But in this case, I can use this external solar panel as a recharge to recharge this MEC on the ADP kit, which then I can use to power my external application. So here I can model a solar panel powering my external application and determine over time whether or not I have energy balance. Energy balance is a very important concept in energy harvesting. It means, is the amount of energy you're getting in greater than the amount of energy that you're putting out to your application? If it isn't, if you don't have sufficient energy coming in, what you're going to find is that your battery or your power source or power storage unit, whatever you're using, is not going to be sufficient to run your application indefinitely. So if you have a wireless sensor module or wireless sensor node out there, for example, and you have a solar panel on it, you need to make sure that you're getting enough energy over time while you're operating the device to make sure that you never run out of power and then lose the function of your end device. So here I've connected the positive and negative terminals of my demo card to the positive and negative terminals, Sentry terminals on the MEC card. Now these terminals are not normally live. They have to be connected through a relay that's inside the ADP kit. So right now there's no power supplied to my external load. So everything is safe right now. I don't have to worry about damaging anything. So if I put it into Sentry mode, what I have are several options. I have Sentry Start. Now Sentry Start simply drives the external load directly from the MEC. But there's also EH Sentry Start. Now Energy Harvesting Sentry Start allows me to drive the external load while simultaneously harvesting energy. And this can be very useful to see that energy balance, and I'll demonstrate that here right now to show how that works. So I'll go into Energy Harvesting Sentry Start. So I can see I've got 4.05 volts supplied to my terminals here. I'm harvesting on the screen here 176 microamps, and I'm storing that information over here on my laptop. So what I can see basically is over time, and this will run indefinitely unless the MEC becomes over discharge. So if the over discharge hits a cutoff event, in other words 2.1 volts, the ADP kit will then cut off the load, the MEC to the load, protecting the MEC so it doesn't become over discharged. If my voltage on my input becomes too high, in this case, let's say it goes up over 4.2 volts, the ADP kit will additionally prevent the MEC from becoming overcharged. But what I can see is over time is as my application is running, I can track this voltage and this current and see whether or not I'm getting enough energy to keep the device running. And the way I'll know is that if my voltage keeps going down, in other words, it doesn't hit a stabilization or balance point, or if my voltage doesn't go up, meaning that it's continuing to recharge over time, so I've got an energy balance that is in excess of what I need. If I don't have either one of those two conditions, in other words, the voltage keeps dropping till the MEC becomes fully discharged, that means that I'm not getting enough energy from my energy harvester or from my environment. So here I can activate my card, and you can see these LEDs are blinking here on the card right now. So the card is currently running from the MEC, and I can see the voltage that the battery is dropping to while it's under load. So it's dropping down to around 3.96, 3.95 volts or so during the activation of the card. So anyway, so that's an overview of the functions and features of our application development platform. If you'd like to see more, please go out to our website at www.infinitepowersolutions.com and let us know. Thank you.